Hi, Richard here from PR Technology, and today I'm going to show you one of the common problems that we have with magnesium crankcases when we're rebuilding the engine. Have a look down here. This is an engine that's just been pulled apart. It's not clean yet. You can see the crankcase is in one piece. We have coming through here all the through bolts, and this is where the barrels sit on the outside. You also see that the head studs screw into the block directly around each of the barrel spigot holes. And that's the little problem child that we're going to talk about today. So it's quite common, these threads in the blocks, to strip, and in fact we can't ever rebuild one of these magnesium crankcases anymore without repairing any potential problem that we have with these holes. Okay, so this is the head stud that we have that I just showed you in front of that engine, and this is my wonderful little drawing here, represented with the head stud going into the crankcase, the barrel around it, and then the cylinder head. If we move down to a drawing of the head stud that is blown up, so this head stud part here is the same as this little bit over here. Every time you run the engine, the barrel up here gets bigger because it heats up. Okay, so this barrel actually expands, let's say 0.2 of a millimetre from cold to when it's hot. What that does is it stretches the head bolt every time the engine starts up. So if this is the head bolt and it stretches, the very first thing that gets impacted is that the top thread on the magnesium, so this is the magnesium case here, the top thread pulls a little bit and starts to get damaged, the very top. Now that's fine for a little while, but over many, many heat cycles, 50 years, once that top thread is damaged, then it comes down to the next bit of thread, it starts damaging that. And then the next bit of thread. And eventually, just from this head bolt moving up and down 0.2 of a millimetre over years and years, it wears away the crankcase because the case is magnesium and it's quite soft. So that's the problem. So even though you think the engine hasn't done much work, you know, it looks quite good, all the metal fatigue on these threads is the problem that we've got to try and rectify. The solution we have is a thread repair insert, which is this little sucker right here. So it's threaded on the inside and the outside, and what we end up doing is machining the case so the insert sits around the stud. So we end up with a piece of steel in the case, both sides, which spreads the load to a bigger diameter, which gives it a better bite, and it's a harder material. So it'll spread the load from these parts down through the steel and share it. In effect, making the stud stretch without damaging the crankcase. So here we have a little sample block that I've got to show people how this works. And there's a few stages in doing this. So the number one thing is we drill out the hole with the old thread in it. So we remove the thread. Then we tap the hole. We tap the hole. We insert the thread repair, and this is called a time insert. So that's a branded insert. And then after it's been put in, to set the time insert, we put in, it's like a dummy tap that's smooth, and that gets forced through the hole, and it forms the threads at the bottom of the time insert to expand the bottom, and that locks it in place. So without locking it in place, it would come out. So this tool, this setting tool, goes in and it locks it in place. And the finished result is you can see that we've got a cutaway down here. We've got a time insert that goes in, the thread repair is affected, and it's pretty much fixed for life. So here we have a crankcase that's had all the machining work done to it and the time inserts fitted. You can see the time inserts are pretty much flush with the case around the spigot of where the piston and barrel sit in. The other thing that we do is that we machine this face, which is where the barrels contact the block, okay? Because after many years and heat cycles, this face is no longer strong either, or no longer flat. Likewise, the spigot holes need to be machined because when the time inserts go in, they deform the holes as well. And with a whole lot of age, these holes are no longer square or round. Square is an engineering term, round is what we want. So the barrels are ready to go for new studs to be fitted and the engine assembled. So at PR Technology, we do lots of these crankcases, both for us and for other workshops around Australia. I hope that makes sense and shed some light on what actually goes wrong with these magnesium crankcases. And I hope you enjoyed the video. Thank you.